Michael, the Mercedes guy here, and I'm going to show you a trick for taking out bolts that are threaded either into aluminum or even steel. What happens, especially with aluminum, over time there'll be corrosion in there and you can break the head of the bolt off. Or other times, the bolt will strip out the threads in the aluminum. So the trick is to heat that up really hot, then quench it to cool it, and then take the bolt out. Now you may think, well, why don't you take it out when it's hot? Well, when it's real hot, that bolt is slightly expanded, which doesn't help us. What we want is the bolt contracted. So we're going to expand it first, then we're going to contract it, then take the bolt out. And I'm using my nice Harris torch. If you don't have a Harris and you do a lot of gas oxyacetylene work, get one of these. They have a valve right here so that you can turn it on, turn it off, turn it on, and it's automatically adjusted. You don't have to be turning off these valves. Not only will it save you a lot of time, but it will save you oxyacetylene gas. So when you're doing this, you want to protect your eyes, not only from the brightness, but if there's moisture down in there, it can blast out of there like a blowtorch. So you get that bolt head red hot, move on to the next one, and so on. Okay, now on this housing, it still has the remnants of the coolant bypass tube. This bolt is fine threads in there, and boy, lots of times it'd chew the threads up. So I've already heated this red hot and quenched it in a bucket of water. But now what I'm going to do, because I can actually heat this boss, and that will expand slightly, which will aid in that bolt coming out. And you don't want to heat it very much. That's about all you need, or you'll start melting the aluminum. And take the bolt out while it's hot, while the housing is hot. The bolt is cold. And to really tell for sure that we didn't damage anything is just to take a look at those threads, and they didn't bring out any aluminum threads with it. So we got good threads in here. So this is going to be a good housing. The next thing we want to check is how much corrosion there has been. We'll go out here in the sunlight, and boy, this has got a bunch of crap in there, but it corrodes right here in this machined smooth surface. The impeller forces coolant against that, and also because it's machined smooth, it has more of a surface for corrosion to happen. And I cannot feel any pitting in there. Of course, we're going to clean this up real good with a wire wheel and a small wire wheel and a drill. But, and the other place to look is right here, where the hose is against it. And it feels pretty good. Of course, we gotta, do some clean out here with a big drill. And that car down there has been sitting a while that we took this off of. But this is gonna clean up pretty good. I got some wire brushes we can put on drills. A couple of different drills maybe, and to really clean this up. So, and this one has the required recessed bolt hole that's to clear the balancer. Okay, on these coolant aluminum parts, this is the best one I have on the place. It will work, but you notice it is a bit corroded here. So what you want to do is dig down in those holes and get that corrosion out of there. And when we put the hose on, we're going to use hardening type Permatex. This is called #1. And this will set up hard, and it's what you want to use on all your coolant connections, hoses, as well as gaskets. And when you do a gasket, put it on both sides of the gasket. So I'm going to dig this corrosion out of here. That way we're down to some pretty good aluminum. And once the hardening Permatex goes on there, that will be a barrier, and that will last for many, many years. So we're just, because the wire wheel won't get in there real deep, I'm using a pretty sturdy, pointy tool here that I made out of a screwdriver. And you want to get it shiny. So down in those holes, get that shiny. Okay, that's pretty good. Okay, next step, which I've already done, is to use a pair of vice grips and wire wheel those threads so they're nice and clean. Now, the threads in here can sometimes be so corroded you'll start putting a bolt in to tighten the water pump on, and things go wrong. So, always tap them out first. And make sure you have the correct tap. It should just go in there with your fingers. And this way we have a nice clean surface, not only for the bolt to go in, but since these bolts go through into the water compartment, we need to put sealant on the threads. And if you got old funky threads, you aren't going to have success with that sealant. So you want to have the bore threads clean and the bolt threads clean. Okay, I've got those threads nice and clean, as you can see. Now, the threads for this water bypass tube. In my Craftsman metric tap and die set, I do not have a tap that size. So what I've done, I found a tap that has the same pitch. That means it has the same threads per millimeter, centimeter, same pitch. It's smaller, but it will still work. What I do is I slide it in there and just push it against the threads, and it will actually clean those threads in there. It's like, as you can see, it's a little small, but by pushing it all the way around, This direction, this direction, this direction. You can get those threads nice and clean. Okay. And this surface must be nice and clean as well, because we're going to put a sealing washer on there. They're aluminum sealing washers. And we got it nice. We're ready to go. We're ready for assembly now. Okay, whenever you're dealing with coolant parts, like this piece we're going to be bolting on, you want to know if the bolt holes go through into the water jacket. That one doesn't. That one does, look at that. So that one we need to use sealant on. And not only that, but for the sealant to work good, we need to really dry those threads out. Like it's impossible to get a tap in there. And since it's in the water jacket, I can see water creeping back into the threads. We want that dry for the sealant to work. So we're going to lower the car and get all the coolant out, and then raise the car. That way we know those threads will be dry. Okay, our gaskets we're coating. You don't really coat the gasket separately because you can break it pretty easy. So I do it this way. And on the block, I've made sure that it's absolutely clean and dry. Very important. And I have coated these two bolts. And so we're ready for this to go together. And as I noticed when I was taking it out, this bolt has to be in the hole and then put it in place, because there isn't room enough to put the bolt in afterwards because of the balancer, actually the dampener that's in the way here. So we're gonna get this down there where it belongs. This is a little bit difficult. So I'm actually going to start this bolt first. And then do the other one. Okay, I've got both those bolts started. But this is very important. You want to take a look down in there with a little mirror and make sure that the gasket is in place. And I can see that it is in place. So we're set to go here. Now on many models, there's a hole right through the dampener. So it's very easy to access this bolt. In that case, you bolt the water pump on the housing up on the bench. Then you install the whole assembly. But since it's very difficult to access this bolt with the water pump there, it would be very difficult to really get it in just right. So housing on first, then the water pump. Okay, I've got a little bit of solvent on this paper towel. Lots of times these will have a little bit of coating of oil on. And that's going to not be good, because we want our gasket compound to stick to that. It won't if it's got an oiled surface. As you can tell, it probably had some oil there. And I also do the same thing to this gasket surface. I cleaned it with a wire wheel, but we're making sure. Okay. Now, we apply our Permatex first to this surface, then put the gasket on and coat the gasket. Okay, I put plenty on there, so I've got it saved on my finger. And then we're gonna put the gasket on. Now, a trick. Sometimes these gaskets shrink and they won't go on. They won't line up with bolt holes. The trick is to soak it in some water. And yes, it's a gasket that needs sealant stuck to it, but if it's not the right size, that's what you end up having to do. And you notice I'm getting sealant all around the bolt hole. Okay, we're ready to go. The next step, the bolts. And like I mentioned earlier, you need to coat the threads because they go right into the water jacket. Okay, which way does the water pump go on? As you can see, there's a scallop here. There's also a scallop right here for this bolt. So that scallop lines up. Okay, so I know that our water pump is gonna fit. Without a problem. So I'm gonna go ahead and put in these other bolts at this time. Then I'll bolt that water pump up tight. Okay, these do go into the water jacket. I poked in there with a wire, so we've got a thread sealant here as well. Now, as you notice, I haven't bolted this water pump up yet. I'm going to do that immediately. You don't want to, do it the next day or something, or that sealant will be dried and it won't work. Okay, I've got these kind of snugged up, and you always want to get all your bolts started before you tighten any of them. Moving this around, get it lined up. And we got one more bolt. Now, as you notice, I haven't put the water pump on yet. On some cars, there's a hole through this dampener, and you can access this lower bolt easy. So on those cars, I'll bolt up the water pump to the housing up on the bench. But on this car, it's so difficult to get to this bolt. It's easier with the water pump off. I did stick it up there to make sure it fit, so I'm fine with bolting this assembly up now.